So we are live.
And Shivam, just share your screen, huh?
Oh yeah. Okay, so our today's question in Leetcode is night dialer, in which we have been given an numpad and okay, let me explain. So basically we have been given a numpad and we have been given a night and we can only move positions in a L shape like mm, for example we are at position 1, then we can only go to either 6 or 9. Sorry, either we can go to 6 or we can go to 8 as a night moves. Mm, and from 2 we can go to 9 and 7, and if we see about 3, from 3 we can move to 4 or 8. So this is basically a question, and if we see from position 5 we can't go anywhere because we can only move on numerical digits. We can't move on these red symbols. So we have been given an integer n and we need to return a number of distinct numbers that we can dial on a numpad using the night moves. So how we can approach this problem is, first of all, we can basically initialize a vector with a current position of having 10 values, which each with a value 1. So if we see about, if we are given a value 1, how we can move from 1, we can move to the positions either 6 or 8. So we can write it basically 2, and if we see from position 2, we can move to either 9 or 7. So it's also 2. And if we see from position 3, we can move to either 4 or 8. So it's also 3. It's also, sorry, 2. But if we see from position 4, we can move to 3, we can move to 9, and we can also move to 0. So for 4 it will be 3, and for 5 we can't go anywhere, and for 6 we can also move 3 positions similar to 4, and for others also 7, 8, 9 and 0. For 7, 8, 9 we can again move 2 positions, and for the 0, if we can see, we can either move to 4 and 6. So if we calculate all of them, it will be 6 plus 6, 12, 12 plus 18 plus 2, 20. So for n is equal to 2, we can, so as you can see here also, there are all the valid combinations that are possible for n equal to 2. And if we see but 1, if we have only of length 1, so we can move 10 positions, as we can move from 1, we can move either to 4, so from 1 we can move to either 8 or 6. So like this there will be 10 distinct numbers as the numpad is of length 10. So how we can code this is, first of all, we can initialize a vector current position of length 10, and we can initialize all of it by 1, and then we can initialize a temporary vector new position, and there we can calculate the sum of all the positions possible, like from 0 we can move to 6 or 4th position, for 1 to 609 positions, and for 5 we can't go to any source 0, and we can, after calculating all the new positions, we can initialize it to our all current positions. And after moving out of out of the loop, we can calculate the sum of all the available positions out there. And we can also do more, because there's a given that the values can be larger than integer value. So let's run this. So yeah, as you can see, the test cases are first. Let's try submitting it. So yeah, it got submitted successfully. Now to using them.
Okay, okay. So Shivam, is my screen visible at the moment?
Yeah, yeah.
Okay. So guys, the question that we have been asked today in our today PODT is that we have been given a graph, and as a result of that graph we just have to return that whether this graph includes a circle, a cycle, or not. That is the only thing that we have to do. So let's just understand it by the help of an examples. So here we have, I have already written down three examples as you can see. So in example one we can see that this graph is just a straight line in which there are edges and there are nodes, and we can see that there are no circles that are forming in this class. So there are no circles that are forming in this class. Now, if we move on to the second graph, we can see that this graph is actually following a circle, and we just have to return true if the graph is following a circle. So in this case, it will, the answer will be true, and for our graph 1, the answer will be false. Now, for the third example, as you can see, yes, this graph includes straight line, but there is also a circle that is forming in this graph. So as a result, we are simply going to return true for this graph, which dictates that this graph contains cycle. So now this is just the visual identification that, yeah, we can see that the graph is forming a cycle or not. But how can we actually elaborate this thing to our computer, to our compiler of that computer? So for that we have to devise some sort of strategy, some sort of algorithm to solve this problem. And the way we are going to do this thing is by BFS traversal. Now, if you understand BFS traversal, then that is actually a good thing. And if you don't, I will make it very simple and clear for you guys by solving the given examples that I have drawn here. Now you can see that in BFS traversal B, there are two or three things that you just have to remember. The first thing is that we are actually going to consider a queue in BFS traversal, and then we are just going to put in the for loop, we are going to apply a for loop, and we are going to travel each node in our BFS traversal. And while we are traversing that, we are just going to put that node in our queue. And then after we have traversed through that, we are just going to remove that thing. So you understand guys what I'm saying? What I'm saying is that in our BFS traversal, we will take a queue. In that queue, we are going to put the elements where we are right now in our for loop traversal. So let's just say we are at node 1. So just we are going to put that node 1 in our graph, in our queue, and just move on to the second node. As we move on to the second node, we are simply going to remove this thing, this node 1 from the queue, and then we are going to traverse to node 3. So node 3, where here we are, just remove 2, and so on. We'll move to node 4 and just remove node 3. So that way we are going to do our BFS traversal. That is what it is in terms of graph. Now let's just understand that how we are actually going to solve this problem via this approach. So here we have a graph, and as you all can see through the visual depiction, by just looking at it through our naked eye, we can see that there is a circle that is forming in this graph. and in the compilation to the compiler of the computer, we just have to tell him that there is a circle following. So for that we are now going to write an algorithm for it. So now for any given graph there is a adjacency list that is formed for a respective graph. So what is the adjacency list? Adjacency list is that for a particular node where that node is approaching in that graph. So you can see that for our given graph, for node 1 it is approaching to either to 2 or either to 4, and that is what I have written here. Either it is approaching to 2 or to 4. So go on and let's just now pick any random node. Let's just pick as node 3. So we can see that node 3 is either it is going to node 2 or node 4, and that is what we have written here. For node 4 you can see that either it is going to node 1 or node 3, and that is what we have written here. So first of all we are going to create an adjacency list of this graph, and usually in our question it is given to us that the person who is asking us the question, they usually provide us with the adjacency list. So that part of us had been solved in this case. So this is the adjacency list for this graph. Now I'm going to traverse this graph from node 1 till node 4, and during this process we are just going to detect if there is a cycle included or not. Now in our queue what we are going to do, we are going to place elements in our queue in terms of node and its parent. So now we are actually starting from node 1. So as you can see that node 1 is the starting node. Yeah, you can see that node 1 is our the starting node, and there is no parent of this node. Like no one is trying to, or no one is dictating her or this node that hey, go this way. So we are just picking this one as a starting node, so that is why the node will be our 1 and the parent of it will be -1. Okay, then for this node, I am going to do a for loop. I am going to traverse through its adjacency node. So for its adjacency node, here I have 2. Okay. Now along with that, as we are solving this problem, there is an array that we also going to construct while solving this problem. And that is a visited array, and it is very important when it comes to solving problems of graph. This visited array size will be equals to the size of the node that we have in our graph. As you can see, there are 4 nodes available in this graph. That is why 4 is here. Now as I already told you, we were at the first node and we are starting to traverse through our graph via this node. So as I am at the first node, as I put this node in our graph, I am simply going to tell my compiler, my computer, that hey, one had been visited. Okay, one is visited, and that is why we have placed one here, and for the other places there is nothing available there. Now after we have put the node in our queue, the next thing that we are going to do, we are going to traverse through its adjacency list. So the first element that is available here is what? 2. So now we are going to traverse to 2. Okay, so here the visitor will become 1. We are actually going to traverse to 2, and who is the parent of 2? As you can see in our graph, it is what? 1. So that is why we are actually stating here 1. Then again 4, as we have already done 2, now we are actually going to move to the another element, which is 4. So as we can also see that 4 is not visited in our graph. 4 is not visited, guys. So we are actually going to mark it as visited and push it in our queue. Who is the parent of 4? As you can see, it is 1. And then, as we have already traversed through one of this graph, we are simply going to remove it from our queue. Okay, so after we have removed it, then we are now going to move to our second element of that graph, of that queue that is available. So for 2, we are going to pick. So for 2, now we are here. So for 2, its adjacency list is include 1. So as we can already see that 2 is there and 1 is the adjacency list, and in our visited array it had been already visited. Now mind this thing, this node had already been visited. So what does it mean? It means that either it is forming a circle or either it is the parent. These are the two scenarios that is going to happen in this case. So as we can see that for 2, It is coming from 1, so it is the parent. So this condition is not true in this case, and this condition of parent is true in this case. So we are simply going to ignore this one. Then we are going to move to 3, and for 3 we can see that it had not been visited till now. So guys, we are just going to mark it as visited and push it in our queue. So for 3, now from where does it coming from? It is coming from, at the moment, from 2. So its parent will be 2. Now after that we have traversed through the adjacency list of 2, we are simply going to remove it from our queue. Then the next element that is available in our queue is 4. So 4, we are now going to traverse its adjacency list, and the first element in its adjacency list is 1. So as we can see in our visited array, it had already been visited. Now two situation can arise. Either one is forming the circle, or either one is the parent of 4 of our current node. So as we can see in our graph for this one, it is actually the parent. So there is nothing that we can do. We this condition of circle is not true in this case, and this condition of parent is true, so we are simply going to ignore this value. Then for 3, now this is the node that had been here. Now for 3, as you can see that in our visited array it had already been marked. So as it has already been marked, as I already told you, two conditions can happen. Either it is forming a circle, or either it is the parent. Now 4 in our queue, as we are marking in our queue elements on the basis of node and parent, you can see that for the value of 4, its parent is 1. So if it is not forming the circle, then 3 should have parent 1. Is it or not? Yeah, it is. So 3 should have parent 1. But in our queue, we can see that 3 here has parent 2. So what does it means? It means that in our graph 1, 2, 3, and 4, this is a graph that I have already drawn. Yeah, and these are the values that we have already reached. This value I have written, this value I have written, and this value I have written. Now I am at node 3, and here I am telling that when I am approaching at node 3 via 4, I am seeing that it had already been visited. So there are two cases that can arise in this case. Either this node is forming a circle, or either this node is my parent node. So as you can see, for the value of 4, its parent node is 1 and not 3. So this condition is not true. So only case that can happen here is that node 3 is forming a circle. So that is why we are simply going to return true for this graph. That is how we are actually going to solve this problem. What we are going to do, we are going to take VFS traversal. In that VFS traversal, we are going to take a queue and a graph. Then an adjacency list will be given to us, and on the basis of that adjacency list, we are going to traverse through this graph. And in our visited array, if we find any node that had already been visited, if we find any node that had already been visited, and if it is not the parent node, then that thing is actually forming a circle. Now what does that mean? Let's just say this is our node. These are the three our nodes. Okay, now if I'm going to traverse through this node, I can say that for 1, its adjacency list will be 1, 2, and 3. So when I'm going to traverse through this, I'm going to reach here and I'm going to reach here. Then after that, for 2, its adjacency list is 1. So after I reach here, if I am finding a value that had already been visited in our visited array, because 1 is already visited in this case, 2 is already visited in this case, 3 is already visited in this case. So if I am finding a value that had already been visited in this array and it is not the parent, then that thing is forming a circle. If it is the parent, there is nothing that we can do. The same goes for this example. 1, 2, 3, 4, and 5. So as you can see, this node is going to approach from here, this node is going to approach from here. Okay, so for node 3, its parent will be what? 2. For node 5, its parent will be what? 4. Now, as we can see that these nodes, what I am marking here I am marking cross to the nodes which are already been visited. So as we can see that every node is visited, and each node is coming from its parent. So, but if I connect 5 to 3, then I can see that 3 had already been visited and it is coming from its parent. So what does that mean? That there is another node that is reaching to 3 and which is actually forming a cycle. So that is why we are simply going to return true in this case. So you're understanding, guys? That is what we are doing in this question. First of all, we are actually taking a queue, we are taking a graph, we are taking our adjacency list, we are putting element in our queue through the traversal, through the for loop, and then on the basis of this for loop we are creating a visited array. And if a node had already been visited, and if it is not visited by its parent, then it is forming a circle. If it is visited by a favor parent, then that thing is not forming a circle. That is the simple approach that we are taking in order to solve this problem. So as you can see, that is what we have done. We have taken a visited array, as I already told you. Then applying the for loop, I am just trying to traverse all the nodes of this graph. Then in the detect function, I am just detecting that whether it is forming a cycle or not. In our detect function, what I am saying, that whatever the value for which I am taking the detect function, just mark it as visited. Then take a queue, push element in our queue, traverse through the queue. If I find an element that had already been visited, and if the visited element or visited node is not coming from its parent, then simply return true. It just means that it is coming from somewhere else, and that thing is forming a cycle. That is the way we are actually going to solve this problem. So if I compile this code, you can see that it will work perfectly fine as it is right now at the moment. So there are 1110 test cases, and you can see that they had all been passed. So guys, we hope that we be able to help you understand the today's PODT problem. And with that, over to you, Shivam.
So yeah, guys, thanks for joining with us. We will catch you up tomorrow.
Yeah, guys.
Bye
See
bye,
you
guys.
tomorrow. Same time, guys.